Morning, everyone. Wednesday, March 25th. I'm coming to you live from my living room. I've got the Elmo set up, I've got the camera going, and what I would like to do right now is, if you have your homework from Mondays, when I assigned this, notes 13.1 and your page 378, after you read the chapter, page 378, the questions 1 through 6, I'd like to go over that now, give you some insights about energy and where we're headed here with this. Behind me is the answers to the fill-ins, so let's take a look. I'm just going to go through these quickly, and then we'll go over the questions from the textbook. Okay, so up here, energy, according to your book, is the ability to cause change. I like to say that energy is the ability to do work. We know that work is force times a distance, right? Anytime that something has a force and it moves, it has energy. There is energy created, or I shouldn't say energy created, there is energy. So remember, energy is the ability to cause change, or as I like to say, the ability to do work. Moving right along, there's two types of energy. There's kinetic energy and potential energy. Kinetic energy is the energy of motion. That's when anything is moving, it has kinetic energy. Your heart, hopefully, always has kinetic energy. Okay, when your eyes blink, you breathe, you have kinetic energy. Potential energy is the energy of what we call of position, or stored energy. But before we get to potential energy, we should talk about kinetic energy. Kinetic energy will increase as the speed of the object increases. All right, and also the more mass an object has, the greater its kinetic energy. I probably should refrain from using my colleagues, Mr. Peets and Mr. Keitel, with using mass and kinetic energy and all of that. I think you guys can kind of imagine where I might be going with those scenarios or analogies. Thinking about potential energy, if we look here, energy stored in an object due to its position is potential energy. All objects have potential energy, all right? The ability to potentially, or the ability to move at some point, provided that a force has been given to it, all right? So those are the two types of energy, kinetic and potential. There are a bunch of forms of energy that we're going to talk about as we move through this chapter. The forms of energy and how they're transferred, how energy is transferred, will become very important. It's something that we need to know. Okay, so looking at our fill-ins, all right, energy comes in different forms. All right, anytime we talk about temperature or heat energy, it's thermal energy. If you remember our phase change chart, down at the bottom of the chart, we talked about thermal energy and how really all matter changes phases because of thermal energy or heat energy. Okay, it's the temperature of an object. The next one is chemical energy, and that's just the energy that is stored in chemical bonds. Anytime we can break something apart, not just physically, not just ripping a piece of paper, but when we burn something or think about our chemical changes, think about chemical energy, all right? It's the bonds being broken when we have those chemical energies that change. Radiant energy is simple, it's just light energy. Energy from electricity, this one's tough. It's electrical energy, and then one that we get a lot of energy from, the Kinetic nuclear power plant over on the other side of Rochester, out towards Sodus. We have a lot of our electrical energy that gets powered from nuclear energy, and that's just when we start breaking apart the bonds that hold the nucleus of an atom together. Okay? All right, let's take a look at the questions in our textbook. Hang on, let me get the textbook. All right, here we go. Hopefully you can see that. If we look at number 1, explain why a high-speed collision between two cars would cause more damage than a low-speed collision between the same two cars. What we said earlier, the faster the speed, the greater the kinetic energy. So as kinetic energy, or as speed increases, the kinetic energy is going to increase. So cars that are moving faster is going to have a lot more damage done to them. Yeah, that's why we shouldn't go faster than the speed limit. The speed limits are there for our safety. And when we increase our speeds, we're going to have greater kinetic energy and therefore greater damage to our cars. All right, energy transformations that occur when a piece of wood is burned. Now, this is what we're going to get into it a little bit in the next section, but they're kind of getting you thinking here. So we have a piece of wood. In order for that wood to break and change is we're going to have fire, right? That's a chemical change. So that chemical change means we're going to have chemical energy. The bonds are being broken, and when those bonds break and that wood burns, that chemical energy is transferred to thermal energy, so heat energy, and then also it transfers into radiant energy because we can see by the light of the fire. So that is the answer to number 2. When wood burns, we have chemical energy that gets transferred to radiant energy and thermal energy. All right, how is the form of energy converted into thermal energy in our body? Well, it's chemical energy, because we have the bonds of the food that gets broken down and digested when we eat, right? So that's chemical energy that's going to get transferred to thermal energy. Also, when we're have our muscles moving and we have the cellular respiration going on in the cells to convert the food, and the mitochondria creating that ATP that gives us the energy for our cells to our muscles that allow us to move, and all of the things that we can do that way. So the big one here is basically chemical energy breaking down into thermal energy. That was number 3. So number 4, we've got 2 vases side by side on a shelf. Which one has more potential energy? What do you think? Think about it. How is potential energy related to kinetic energy? We said, if you remember from our fill-ins, right? From our fill-ins, kinetic energy increases as the mass increases or as the speed increases. So think about potential energy, right? 2 vases side by side. Which one would have more potential energy? Not talking about greater potential energy where one's higher, because they didn't say that. They're side by side. According to this question, they're side by side on the same shelf. I hope you said the one with the greater mass is going to have the greater potential energy. Okay, so yes, the one with more mass will have more potential energy. Number 5, golf ball, bowling ball. All right, both of them have the same kinetic energy. So if they have the same kinetic energy, we know golf ball is much smaller than a larger bowling ball. Golf ball has less mass, bowling ball has more mass, but they have the same kinetic energy. So one has to be moving at a much faster speed in order to create the same kinetic energy to balance the 2 differences in their masses. So hopefully you said the golf ball here would be moving faster. Common sense. And then finally, this last part of question number 5. If they're moving at the same speed, which one has more kinetic energy? Obviously, the bowling ball, because it has more mass, okay? That would go back to the analogy with Mr. Peets and Mr. Kydell. Right? Okay. The last one. A sentence or 2 about how we use the word energy in everyday life. There's lots of things. A couple that I came up with. I don't have much energy today. Actually, I do. I got up at about 6:30 and put all of this together as I was thinking, laying in bed for the hour before that when I woke up at 5:30 this morning, thinking about how I was going to do this. Another one I had, that particular student has a ton of energy today. Okay, and I'm sure you all came up with some great answers yourself. All right, that's it for today. I'm going to have out outline 13.1 up on my classroom webpage. I'd like to get that done, try to have it done by Friday. I might come back to you tomorrow, but today is Wednesday, March 25th. Science 8, sign out. I hope you're all doing well. I hope your families are doing well. I miss seeing you all, and take care. See you soon.